Hello, everyone. Thank you for joining. My name is Chris Adams. I'm the online community manager for ModernAnalyst.com, the premier community for business analysts. I'd like to welcome you to today's webinar titled Using Master Specifications for Requirements Variability. Today's featured speakers are Reg Struck, Product Management at Polarian Software, and Linda Gaines, Director of Product Marketing at Vector Software. The webinar will last approximately 60 minutes, including the Q&A session at the end. So be sure to submit your questions in advance using the questions feature of the GoToWebinar software. And at this time, I'll turn it over to Reg Struck to get us started.
Thank you, Chris. Welcome everyone that's attending through the continent and across overseas. It's a pleasure to be here today. And what I'd like to start with is give you a little bit of context about my background. As Chris had mentioned, I am actually a product manager at Polarian Software, and I manage our test management platform. So very well versed, and I have over 20 years of experience in software development, both working at complex environments in healthcare and as well as now supporting customers that are in various environments from pure software to financial systems. So we have a lot to cover today. I would like to just tell you a little bit about the agenda. So what I'll do is talk a little bit very briefly about who Polarian is, so that you have an idea of where I'm coming from. Then I'm going to delve right into the concept of variance management, some of the challenges, what it is, the potential solutions that we offer, and a little bit about product line engineering. And I'm going to pass it over to my esteemed colleague, Linda Gaines, and she will provide some great insight on testing variants, and intro obviously about Vector Software, share and reuse, and managing and scalability within the environment of variants. And then we'll wrap it up hopefully with, I hope, at least 5 to 10 minutes for you to actually be able to share some experience and ask some questions, and hopefully we can answer some of those. So let's get started. All right, so let's talk a little bit about Polarian. So we started about a decade ago. It seems like it was yesterday. And we were founded with a very disruptive vision, and really that vision became a technology. That technology itself is a 100% browser-based product that we launched in 2005. We are what's called ALM, and what that is in a nutshell, if you're not familiar with it, is application lifecycle management, so managing the entire software development lifecycle. And then we have really 4 flavors now, but 3 main flavors of our product. So the whole ALM product, but then also we have requirements management, and then we have test management, which is the product I manage, of course. And then we're proud to have released this year an add-on which is called Variants, which we'll talk and explore a little bit more about today. So we're proud to, I'm happy to say that we've had tremendous growth in the last 10 years, and then we've got just recently about 10 million investment from the VC arm of Siemens for some additional integration and hopefully some even more disruptive technology to be launched in the upcoming year. In this particular slide, it really just shows the diversity of our company. We've got, as you can see, companies throughout the world, also within different types of industries. What's really interesting to me is that we have about a 95% plus retention rate, so we have a very, very loyal customer base, which is nice. And to complement all this is that if you haven't heard of us, certainly you can look at Ovum's reports, analyst reports, and they're reaffirming some of the things that our customers already know. Is the technology that we have that surpasses a lot of our competitors in that customer satisfaction. All right, let's delve right into it. So this is I like this little particular cartoon. So everybody's obviously familiar or should be familiar with Dilbert. Here is a great user story here. So your user requirements include 400 features. Do you realize that no human would be able to use a product with that level of complexity? And the analyst or product manager says, "Good point. I better add ease to use to the list." So really what the point of that is that in today's, in our modern environment, there's a lot of pressure for us to bring products to market with improved quality, but more importantly, more frequently, and also there's an increase in the variations of our products to fulfill that mass customization, which I'll talk about further. What's typical is that we clone these projects and we've traditionally branched them and merged them and so on and so forth. But that's really not meeting a lot of today's business needs. And to make matters even worse is the fact that we're compounded by the simple fact that there's multiple inputs now for requirement elicitation. So you've got your consumers, you have from user stories, your development teams, technology advances, your testing teams, your corporate stakeholders, the competitive industry. All these now are inputs, multiple inputs at any given time to actually provide requirements. So what does that mean? It means more requirements, more features, is a one-to-many relationship and many to relationships. So we've got a lot of inputs that are available. And then the real challenge with that, so yeah, we've got all these inputs, but now we've also have, with the Internet of Things, is mass customization. So now, in every project now, there's there's a need to reduce cost, effort, and their time to market. But at the same time, our customers are actually requesting more and more customization. So they want quality products that are tailored really to their very individual needs. And the experience of this is many organizations that are using traditional ways of actually eliciting requirements and doing development, which focuses primarily on those activities of development and delivering in single project streams, really isn't meeting those needs. It's not really efficient to meet these challenges. And we've got different system configurations, different behavior, different iOSs, different platforms, different devices, different system interfaces, different protocols. So you get the drift. There's so many different things going on. I think this is a great example of variance. So this is, if you're not familiar with this, it's wearable tech, and it's the Fitbit. You're probably very familiar. So there's a base platform, and then you have multiple variations in colors, sizes, and various options. So this is a great example of a consumer product that is various customization and variance. So the typical approach to in the industry has been for these type of projects is to branch and ad hoc reuse some of the artifacts from previous projects. It's inherent for us to want to do that. It's the path of least resistance. And because there's an existing solution, then you want to consider adapting that one. Is it reasonable? Probably not, because and we'll talk a little bit more about why, but there's cost, effort, and time and money, and that is a major impact on that. So there's not a lot of similar solutions that you can reproduce, and you'll still have the savings and get things down to market as fast as that. And then the side effect to that is also increasing your maintenance. So now think about this if you use the Fitbit example, you have now, if you did reuse of these particular projects and you did the traditional way, is that you're cloning this, and now you have several branches to support within your organization. Several of these become different projects. Not very scalable, and it's clearly better to implement some kind of other solution that we'll talk about with variants that runs in parallel. So we don't want, and this is where organizations are starting to feel this, especially in the outside of traditional manufacturing, is that they're spending a lot more time on maintaining and synchronizing changes, and then the impact of changes. Also then ultimately solving defects and resolving conflicts as well. And then also you're trying to, at the same time, is our role really is to wanting to actually add new features and capabilities. So there becomes a paralysis, and it's very difficult to deliver and maintain your existing systems. Okay, so there's some good news. And this is very much, it's called Variance Management. And it's been very much used in manufacturing for a while now. A good example, if you think about automotive, they've been experiencing for a very long time mass customization and even further mass customization of their products. So you have a system, and it's basically a software product line. They call it the SSPL. And what happens is that you create, exploit, and manage on a common platform to develop a family of related products. So that could be anything. It could be software products. It could be integrated systems. The reason why you do this, it lowers the cost. It will reduce the time to market. And if you're doing it correctly, and Linda will talk a little bit more about this, of course, is that you'll improve your quality. So in essence, what we're doing is that this practice is actually a systematic reuse of your existing assets, so that basically the products you're delivering it's still a member of the same family of products, which share common characteristics, but then there are some differences, and those are the variants that we'll talk about. So variability is a product line characteristic that may differ among others. So it could be functionality, it could be the quality attributes, your environments, your constraints and restrictions. Those are all variables that have to take into account. And that becomes a central component of any product line engineering approach. So this concept of many variations in a product, it's not new. It's been commonly known as variance management. What's new is that in the world of software, it's becoming more and more prevalent, and it's being introduced into a lot of the non-traditional, I would call, non-manufacturing, non-mechatronic type situations. So it's an innovative process, allows the highly effective management of your common parts and your variant parts as well. And we'll talk a little bit. I'll give an example. All right, so this particular example we're going to use, we're using our product or solution as well, but the methodology is using what's called agile variants, and there's 4 distinct major steps. I'm going to focus primarily on requirements, and then obviously Linda will take that and move into the testing area. So there's 4 major steps involved in the process. So the first is that you want to define a master set of requirements, so the superset of requirements. And then second is to identify all the possible constraints and restrictions for that set of master requirements. Number 3 is you add the variants that are dedicated to your specific groups. So the actual personas, the ad personam, it's a Latin word for a specific user group. And then last but not least is identifying that minimum set of requirements that is viable for release to the consumer. And I'll go into some examples in detail about this as well. So as I mentioned, step 1 is the superset of requirements. So in essence, this is what we're really doing is continue to use the same type of ways you do things today. Interviews, role, game role playing, diagrams, whatever used to elicit your requirements. If you're doing a good job at them, sure, continue to use that. So that doesn't change. But what's also very, very important is the fact that make sure that everything gets captured. So in that master set of requirements is you want to digitize anything that the mock-ups, the diagrams, absolutely everything should be included in your master requirements. And then the key is just don't worry about prioritization in this stage. So it's really gathering everything. And I'm going to use this example. In this particular case, so this is actually Polarian's variance management interface. It's in our requirements management tool. This is obviously a document, and what I'm using here is the example of headlights. Okay, so this is actually a master document for headlights obviously, and we have high beam, we have low beam, fog lights, indicator lights. So a collection of all the possible. Okay. And then you can see here is that on the right is that you can also define what the criteria is based on. We'll go into step 2 here, but the constraint and definitions, if there's any of those as well. So we actually create the criteria based on the master requirements, which is step 2. So the definition of your features and your requirements. So any dependencies, okay, any conflicts or restrictions, and then links to any at all of everything, diagrams, requirements, documents, etc. And here's an example. I'm using the exact same example, but highlighting, if you look at here, is that so there are some restrictions in this particular case, is that using the car light example, you can see a list of links to other requirements, but more importantly is that the restriction is that high beam xenon must be used for Europe, but is not applicable to North America. So that would be what we would know as a restriction or a constraint, and obviously there's multiple of those as well. All right, so step 3. This is really one of my favorites, is gathering personas. So identifying each persona for each of your variations, and of course the set of requirements that are available for each one. So in this particular case, it's obviously not a real case, but it's we have this car. There's 4 types of flavors of this car, and then you have personas that are based on the 4 different types of people, and then they associate. Okay. So here's the example. So again, it's the personas that are variants. An example here is that we have the high and low beams. So this is really based on the country, and so the type of light is identified based on is either mandatory or an optional feature. So the persona is actually country-based, and then you have a selection of features that are based on that particular feature model. And then further to this example is we can identify from base criteria, which was defined in step 2, if there's any conflicting features, which in this case we would create an error warning. So you'll see that with the X there are some conflicts, and that means that there's. All right, and last, before we get to step 4, there is actually called variant matrix, and that what you would do is a comparison of all the itemized features and commonalities by country. In the case, in this particular case, it could be the bare minimum amount of features. So using a matrix to the most minimum features that there are, and then the last is that we would actually create a release specification. And in this particular case here, oh, there's the matrix. So I had the slides backwards. Sorry about that. So here you can see the actual. So on the left is actually the countries, and then on the right here is the actual features themselves. So there's your variant, and then the checklist is the common and the matrix, and you can choose which ones based on the variants. So as I mentioned, so this is the last one here. The last is the release specification document. So this document, basically what it does is it outlines the basic requirements and the variants commonality. So why do we do this? Primarily as well, first of all, the solution now becomes very scalable. Now you're not branching, you don't have to support these various branches, which in essence, hopefully it's going to help you basically to exploit and develop a family of related products at a lower cost, reducing hopefully that time to market, and then the quality will either obviously stay the same or even improve. That's what we, in a nutshell, is called product line engineering and manufacturing, and is definitely being now applied to software development. So it's a systematic reuse, and the reuse is also the approach that views the products delivered is really by a development organization as basically the same product family. So everything's treated as the same family with the several common characteristics, but then of course the variances, the differences, otherwise would have been different products, but they're actually just variants of that same particular product. And it gives you a full and clear understanding about the variability, and establishes, as you can see from the matrix, the transparency of what the new variants, what they are. All right, so let me just rephrase this. So product line engineering approaches lets you move from a minimalistic approach of reusing common solutions, okay? So reusing your assets, such as your requirement specifications, your test specifications, your code, all for the same product, And then you can reuse those with shared components, and then develop on those shared components the specific solutions to your various audiences. So if reuse is minimalistic, then there's no variation points that need to be formally managed. More balanced approach, though, is probably what you'll be looking at, and the common aspects as well as the shared parts are basically supported in that core platform. It's the variation points for the application that are specific extensions of that platform, and as you've seen from the 4 steps, they're identified as well. So, as you can see, this is definitely an alternative solution to the traditional approach of branching and so on. So now let me pass the presentation to Linda Gaines from Vector. She'll now discuss the handoff from requirements to testing and traceability, and then back to your original specifications.
Thank you, Reg. Well, thank you, everybody, for joining us today. My name is Linda Gaines, and I'm the Director of Strategic Accounts for North America here at Vector Software. I have been with Vector for 10 years in a variety of positions, including Director of Product Marketing. And I have over 25 years of experience with software development and testing, including training and consulting on the application of software development tools and techniques to real-world projects. Our company is Vector Software, my company, not our company. And we've been around since 1990, and Vectorcast has been around since about 1994. That's our product. And we focus really on creating innovative software solutions for improving software quality, as well as reducing time to market through automated software tests. And we are a global company based in Rhode Island, where I'm located. In addition to offering products, we also have a strong global services team that focuses on best practice training and consulting, as well as outsourced project delivery work, including requirements development and testing. So we're a kind of a full-service global organization. Historically, we've worked mostly with safety-critical industries whose primary goal was to deliver correct software in order to eliminate catastrophic failure. So think airplane engine control systems, medical infusion pumps and implantable devices like pacemakers, automotive airbags, and brake control systems. For those applications in those companies, quality is critical because you've got human life at stake. But increasingly, we're seeing more and more interest from companies that we deem business critical. So not the regulated industries like those other ones, but more your more typical companies whose goal is really to improve quality and reduce time to market. So for those companies, testing allows them to do a few things. First of all, it allows them to improve their software quality. Better software means happier customers, more revenue, more brand loyalty. It also means quicker time to market. So testing allows you to get more customers more quickly because you've got the cool new features. And testing also means lower life cycle costs because it eliminates the rework due to quality issues, which are found either in the field, and you can think recalls, that's very expensive, or just late in the project's life cycle that delays your launch dates. So testing for these organizations really becomes a competitive advantage. So Reg talked about Fitbit as an example. I'm going to talk about coffee makers as an example, but they're both great examples of this product line notion or this variant notion. And Reg did a good job of describing what product variants are all about. In my coffee maker example, the same concepts apply. All coffee makers brew coffee, but some also grind coffee beans. All have a place to put in water for the coffee, but some also can steam milk or make latte or do all kinds of crazy things. So you need these other pieces of functionality to support that. And so Reg also talked about the need to have this superset of requirements that's going to cover all the coffee makers out there, but then each specific coffee maker would have a minimum viable requirement set like we talked about. So in this example, the blue dots represent functionality that's going to be common across these coffee makers, and the red dots would represent those areas of variant or unique functionality across those coffee makers. And so once you've got all those requirements documented and specified and allocated as kind of common across all of those products or unique to a specific product line or variant, you can go ahead and build that product, and then your testing obviously starts. One important thing to note that it isn't just the software or the code that's going to vary across product lines. You may need a larger microprocessor or computing power in your commercial coffee maker than you do in your one in your home or in your hotel room. So along with those different target hardware components in a product line might come different compilers, or the same compiler with different settings. You might have a different operating system. So it's not just the code and the requirements that are different necessarily. It's your whole product, your whole environment could be very different from one piece to the next. And so part of the challenge for creating the common code that needs to go across all these variants is making sure that common code can truly run in each of the different environments with each of the different targets and things. So let's talk about testing. All organizations that embark in testing, which is pretty much everybody, face common testing challenges. So you've got large products that are just hard to manage because there's a lot of different types of testing that go on. You've got a lot of users or a lot of testers, all with different results and data that have to be managed. You want to have the ability to aggregate all your reporting, and so it's really hard to do that by hand. And then testing for these large products can take a lot of time. So that's kind of the normal situation. And then when you introduce this idea of common code and variant code, that just complicates things a lot further. So that's why this is such a critical issue. And I want to go back to the slide that Reg put up regarding the kind of the key pieces of variance management, so we can begin to talk about how to address those challenges. And there's really these three principles here to make your product line testing efficient and effective, and that's share and reuse, managing change, and scalability. So sharing of information is all about multi-user collaborative testing. And what does that mean? Well, that means centralized management of the testing for all the stakeholders. So having all your developers and your testers work in a common environment so they can see what other people are doing. We have access to information. And then having dashboards and reports that can automatically aggregate and roll up that information so that management can see at any one point in time what's going on across the entire code base. And the dashboard is key because if your main driver is time to market, you want to be able to know at any point in time if you're ready for release. So it's all about release readiness and being able to say, okay, today we can release, here we go, because you've got all that information at your fingertip and you can make those near real-time decisions. You want to be able to have a common testing configuration. So you don't want all your developers or all your testers to have to know the details of how to run their code on all the different product lines. So especially the folks that are doing the common code, it's going to really bog them down if they have to figure out how to configure all those different coffee makers to get their code to run on it. That's really a good place to take advantage of automation and automated tests, to just say, okay, I've got this common code, go ahead and test it across all of those product lines. In addition, the developers really need to have access to all the source code and all the tests, because it's not just about testing their code on the stuff that they think it applies to, but really allowing them to assess every change they make to the code to see how it's impacting other things. It could be that a change to common source code impacts some product lines, but not all product lines. So being able to run all the tests on all the product lines all the time is going to ensure that you've got good quality and you don't get surprised later. I talked about that dashboard for reporting, so being able to really visually see your trend, okay, where our success rate of pass fail is going up, our completeness rate is going up. You know, you want all your graphs going up and to the right. And then release readiness can get into some of the details of that and being able to look at specific test groupings of each on each build or each test run and say, okay, what's our percentage? You know, what's working, what's not working? Where do we need to focus our efforts to get this release out the door? So then reuse of tests for the common code is going to be really important. You want to be able to build those tests once and then, as I said, rerun them on all those variants over and over again. So oftentimes what happens is that companies will test one or two variants and then wait to test all the variants close to release time, if they even do it at all. By doing that, you're pushing off the testing until the end of the life cycle. And any issues you find get kicked back to engineering, which causes schedule delays and possibly even more regression issues in other parts of the product line. So what you want to do, as I said earlier, is you want to test that common code on all the variants all the time. That's what's going to keep the quality high in all the product lines and reduce the overall testing time because you're not finding stuff late in the cycle. So this all really lends itself to continuous repeatable testing where your code and your tests stay in sync and you're able to really manage this stuff on a regular basis. So I have a diagram on the right of the coffee maker and different models, and you know, they all brew, so that's your common code. But the office model probably has a bigger water reservoir, handles water differently than the others, so you may have some specific code around that. But when you add up the common code across all the variants plus all the variant code, you've got a very large application. And so that's going to require a lot of testing. And running all the tests can take days. And so what really helps with that is something called change-based testing, where you're only testing the things that have changed from test run to test run, and not having to test everything all the time. And that really reduces the time it takes to test all those variants. So that's really nice. The other thing to note is when you have those common set of tests, you want to be able to just replicate, you don't want to rewrite them. You just want to reuse them as is, drag and drop them from one configuration to the next, from one product line to the next. So the managed change principle that we talked about before is the next one, and that gets into that change-based testing I just mentioned. Your code base isn't static. It's constantly changing. And a change in one area can have an impact that isn't obvious in a seemingly unrelated area of the product. So it could be that a change to the common code impacts some variants, but not all variants. And you want to be able to test, as I said, all the code changes and all the variants to make sure that doesn't happen. But that can be a lot of testing. And so what that does is if you do all that testing, it could impact your budget and your delivery and that sort of thing. And so what change-based testing does is it allows you to reduce those testing times because it's figuring out what small subset of tests need to be re-executed based on a code change. And that's done quickly, and it helps move that testing back into the engineer's lap versus at the end of the life cycle in the QA team's lap. So it allows the engineer to assess what small subset of tests have been impacted by a code change and allows them to execute only those tests, which is going to greatly reduce the test time. And that way, when they do find out if something broke, it's fresh in their mind, it's easy to fix, and they can address it right away. And so you can make many code changes and do a small set of testing based on each code change and accomplish a lot of work in a day doing that. And when you do run all the tests at the end, you're unlikely to find major errors because your master code base is never broken because the regressions aren't introduced into it. The developers are catching them before they even get into your master baseline. So the idea is test less stuff because you can do it more quickly if it's less, but fail faster. You want to find the tests that are most likely to fail based on a code change and find those out right away because that's what's going to reduce your overall testing times and decrease your time to market. So by way of example, we've got a file of code on the left that's just a small piece of the entire code base. The red one is something I've changed, and then we've got a whole bunch of tests on the right there, but only 4 test cases are really impacted by the source code change. So I just want to run those 4 instead of running all those other tests. Again, drastically decreasing the amount of testing time that takes. And so what Vectorcast can help you do is it can say, okay, for this particular test environment, there's 5 total tests, but only one of them required re-execution. So let's go ahead and re-execute that, make sure that that's still passing and that everything that was expected is still happening. And so I've reduced, down to 20% the number of tests that need to be rerun. And then the last principle is scalability. As I mentioned, the change-based testing allows a lot of testing to happen in small subsets continuously. When you do want to run all the tests, and you are going to, at the end of your life cycle at least, want to rerun everything on all those variants, you want to have enough processing resources to support parallel testing. And that comes in handy if you're going to do a continuous integration, continuous test approach as well. So you want to be able to do parallel testing and test things on multiple, whether it's virtual machines or whatever, be able to do that. And so continuously building and testing the software is what's going to decrease that testing time. And obviously integrating with a continuous integration solution like a Jenkins or something like that can really help to make that happen. So then to tie all this back together, the requirements are going to define the product variants, and the testing is going to ensure that each variant does what it's supposed to do, not more and not less. And so the product line requirements should be able to be mapped to the tests to ensure that the tests, to ensure that all the tests map to a requirement, and then all the requirements need to map to a test. So you need to make sure that each product line, the requirements for that product line have been tested. So all those requirements need a test. And you want to make sure that the tests are all there to support a requirement. You don't want any software in there that isn't supposed to be in that specific product line. And so Vectorcast and the Polarian ALM tool have a really good integration to help close that loop between requirements and test case data to make sure that it's all working seamlessly. And up in the Polarian solution, you can do that traceability to the various artifacts of the product line development. So that is what I wanted to say today about testing and testing of variants. And as Reg mentioned a minute ago, I think we have some time for some Q&As. Okay. One of the questions that I see that looks like I can answer is, how does Vectorcast actually know what tests are impacted with the change-based testing? And the answer to that, without getting into the complexities of it, is at a high level, it basically looks at code coverage. So there's a technique out there for code coverage analysis which allows you to, for every test, to see which actual lines of the software code that you're executing. And so when you change a line of code, the Vectorcast tool can actually tell you which tests executed that line of code, and therefore which tests need to be rerun because that line of code has changed. So code coverage analysis is typically used for thoroughness of testing to assess, where you've tested your application well and where you've got gaps in your testing. But in this case, it can also help with change-based testing. There was a question about agile testing tools. Without knowing the details of that, agile, for those of you that aren't familiar with it, is an approach to more easily meet the challenges of large software development projects by breaking a very large project into small pieces and doing it kind of in small bites, if you will. One of the principles of agile development is something called test-driven development, which means building your tests in parallel with building your software. So starting with your requirements, you've got somebody writing tests, and you've got somebody else building up, somebody writing tests and somebody writing the code, and they're both looking at the requirements. One of the problems that happens with software development is that people use the code to write the test. So it's kind of not always optimal because your code could be wrong. So if you're using code to write your tests, then your tests are probably going to be wrong too. Ideally, the code and the tests both need to be developed from the requirements directly. So I know for Vectorcast, which can support an agile approach and test-driven development, that you can write tests without having code written, and you basically need header files, if that's familiar to you all, a very minimal set of functionality such that you can, get an executable to run, and you can build tests and they will execute and they'll fail because they're written to requirements and there's no actual code to do anything yet. But over time, as you continuously run those tests, you can see them start passing as the functionality is introduced. So that is one way to support that. But in general, I think what I've seen for test-driven development and agile programs is it's really just about repeatability, both within kind of a sprint and also across sprints. So again, making sure that you're always running your tests and that things are always passing the way they should be, and that once you add new functionality or new code, you're not breaking something that you did previously. And the only way to assess that is to have a baseline set of tests that is going to get you that. So looks like there's a question for Reg about requirements traceability matrix output. I will let him address that if he pops back in.
I'm back on here, Linda, but I don't have access to the questions, so
okay. Well,
can you hear me?
I can.
Great. Can you repeat the question for me, please?
Yes. Does your tool provide requirements traceability matrix output?
Good question. Yes, we do actually provide. So the tool that I was briefly showing does provide traceability matrix output. In fact, there was a slide that showed a matrix, which is basically a deviation of our traceability matrix. So yes, we link from your requirements. The product actually links from the requirements all the way to your source control. And Linda's product actually, our requirements link to their test cases. So there's complete traceability with other third-party vendors as well. And you can have it in any format you want, whether it's on the web platform or whether it's in a PDF format. So absolutely.
Here's another question for you. How do you organize requirements in the tool? Do you use parent-child links? How do you organize requirements in the tool? Do you use parent-child links for breaking them down? In which case, how do you link the common requirements to lower-level requirements that can satisfy several features?
Oh yeah, I can actually see. I have the panel now. That's a great question. Okay. Yes. So can you still hear me?
Yes.
Okay. So the way that our product is actually stores everything, it's actually in individual objects, and everything is considered treated as a work item. You can have a relationship of parent-child relationship where it's a one-to-one relationship, a one-to-many, and a many-to-many relationship. So you actually can have those links within the actual individual work item, as well as if you wanted to look at them from a document-centric view as well. Hope that answers your question.
There's a question here, is what needs to be tested decided by the developer? I think I will take that one. I think in my experience, every organization does things a little bit differently. If your organization is committed to requirements and testing the requirements, then the requirements are really going to drive what needs to be tested, and those are going to be the baseline of the tests that are created. If your organization is a little more lax on requirements, then I think the developer, is going to have a better feel for what needs to happen because they're the person that actually did the implementation of it in the software. I think I mentioned code coverage a few minutes ago. If you have kind of usability or system tests, full application tests, if you deploy code coverage metrics or code coverage analysis on that, you can see, the areas of code that are tested through your just playing with the product. You can look, more importantly, at the lines of code that aren't tested. Those are typically your edge cases and your error conditions. So a lot of times organizations will use that information to drive what tests need to be developed. So, that's a strategy. You can use code complexity metrics. So those areas of the code that are really complicated, you're going to want to do a lot more testing on. The areas of code, if you've got a legacy product that tend to break or that are fragile, you typically want to add some extra testing in there and focus on that. So there are quite a few different strategies you can use on where to focus your testing resources. Reg, do you see any more questions in there that you want to address?
Yeah, absolutely. There was some audio issues, and there might have been some confusion. I noticed that there was actually some comments about some confusion, probably because of the audio. I'm hoping it was because of the audio. There is actually, I had mentioned about requirements and that reuse. What I'd intended, or what was implied, was that we do actually reuse the common set of requirements. So I'm not suggesting that we actually just throw away requirements. So the common set of a base platform of requirements, and again, this is, just remember that what we're talking about in this particular scenario is that you have a product that has variants. So there actually are customizations of various products on that base platform, like the example of the coffee maker or Fitbit. So we're not saying that you don't reuse any of your requirements. What we're saying is that the existing platform of base requirements are reused. It's what isn't is the customization. So those personas that I outlined, those would be the unique requirements that get used. And even some of those will get reused as well in those variations. So certainly wasn't implying that we don't reuse requirements.
Thank you guys for a very informative presentation. Reg and Linda, much appreciated. Thank you all for attending today's Modern Analyst webinar, and this concludes today's event. So have a great day.
Thank you.